Hello everyone, this is Min Sum. I'm the Chief AI Scientist at Appier. Welcome back to the AI Expert video. Today we're very glad to have Professor Greg Mori, who is the Research Director of Borealis AI Lab in Vancouver, as well as the full Professor in Computer Science at Simon Fraser University. Welcome, Greg.
Thanks very much, man. It's my pleasure to be here.
Yeah, I have met Greg several times throughout this year because we're both focusing on computer vision and machine learning area. And I think I first time met you in 2009 in Kyoto in a conference, and also in 2016 back in Taiwan for another conference. So really great to see you once again, especially in this video.
Thank you.
So today I will ask about your backgrounds and also talk about, do you have any questions or any suggestions to the AI community in Japan? Right, so let's get started. So Greg, can you share about how did you get started in doing research in computer vision and machine learning?
So it's interesting. It's actually started when I went to graduate school. I did my PhD at UC Berkeley, and I started there in the late 90s. And in the late 90s, computer graphics were actually a very exciting field of research. And there was the first animated movies using computer-generated imagery were coming out, and it was a very exciting time for that field. But when I met my supervisor, my PhD supervisor, Dr. Jitendra Malik, he convinced me that solving the inverse problem, so rather than generating images with computer graphics, instead understanding them would be a much more fruitful area of research. And it was a bit serendipitous, but that was the start to my career.
Wow, awesome. I think Professor Jitendra Malik is very good at convincing people.
Absolutely.
Yeah. So, and you have conducted research in this area many years. Can you share about what is your initial direction and what is your new direction now?
Absolutely. So I've always been fascinated by every form of visual recognition. So taking in images or videos and trying to automatically figure out what's inside them. And specifically within that, I've always been attracted to the field of understanding and recognizing human actions. So trying to understand either a single image or a video and determine what's happening inside that.
That sounds awesome. And I remember once in our conversation you mentioned you're using that technology to kind of recognize sports events.
Absolutely, and I think following on some of your amazing work on activity recognition in scenes, we've done a lot of things on sports video analytics, trying to understand groups of people and how they're behaving and interacting. And there are many really important applications for that type of technology. Everything from media, where you're trying to help broadcasters build more engaging scenes for games and help people understand what's happening, through to helping coaches and managers select the best teams and strategies to perform well.
That sounds awesome. Is there any such system also deploying hockey play?
There absolutely are, and the state of the art in these fields just keeps moving incredibly. There are companies that are doing great work on providing real-time analytics to coaches, providing offline analyses for managers to try to figure out the best strategies to use. That technology is being used every day now.
Cool. So since you have put so many effort and getting so many great results, looking more into the future, what kind of impact you think you could bring into the human society and also in the industry?
So I think what's very exciting, and this is sort of a golden age for computer vision and for machine learning, is that many of what we would call the low-level sensing problems are near solved. So detecting objects and images, detecting people's actions in videos, these are things we can do quite reliably now. And so what's fun now as a researcher is we get to go after higher level reasoning and intelligence tasks. And the state of the art in these things is moving to the point where we're able to tackle broader societal issues, everything from environmental monitoring to healthcare to transportation to financial services. There are huge industries that can be impacted positively by AI.
I see. So I can imagine in those domains, they could, at current stage, use computer vision to recognize activity, and perhaps future can predict their next activity.
Absolutely, and that's something our team has worked on a lot. It's really exciting not only to see what are people doing now, but being able to use that to infer what actions might the people take in the future. And in a variety of domains, again, everything from financial services, where we want to combat fraud, to understand that someone's sequence of actions are unusual, through to healthcare, an environment where we're monitoring elderly residents in a care facility. There are lots of important reasons why we need to be able to predict what will happen next.
Sounds cool. So if we can predict next, we can take action now and benefit the whole society.
Absolutely.
So Greg, I also heard about in the past 1 year you kind of transitioned partially from the university job also into the Borealis lab as a research director. Can you share about what motivated you to do that and how things are going there?
Thanks, Min. So I've always been very interested in industry collaborations. As a professor, I actually worked at 3 different big tech companies and was involved with 9 different startup companies over the 15 years I was a professor. So I've always really enjoyed that interaction of seeing the cutting edge research that we're able to do become products that impact people's lives. That's always been very important to me. And when I was considering what to do in kind of the next step and what was exciting to me, I looked around and I felt that there have been amazing advances by social media and advertising companies that have driven a lot of AI success recently. But there's so much more to the economy and to society than those industries. There, as I mentioned before, things like healthcare, things like transportation, things like environmental monitoring and financial services. And I felt like there was definitely a green field, a lot of open opportunities that existed, especially within financial services, that would really allow me to take the types of methods that I've been developing and deploy them to help make people's lives better. So it's interesting, as a computer vision person, that's sort of my core interest. When I first met people at a bank, Borealis is part of Royal Bank of Canada, RBC, one of the largest banks in the world. When I first met people at the bank, I was wondering, well, as a computer vision person, is there a place for me to help them move financial services forward? And it turned out that there was a lot of commonality between the types of research we were talking about earlier about human activity recognition and predicting future events. Those are things that are very much relevant to financial services. Rather than having videos as our input, we have other sequences of either transactions or stock prices or other information about the world from which we wish to make predictions. So it was actually a very natural fit to kind of transition from this computer vision world to one in which we're working on similar techniques but applied to financial services.
That sounds awesome. So basically the core machine learning technology could generalize well both in visual data as well as the new type of data you get from the banking services.
That's correct. The core underlying machine learning technologies are what we really spend a lot of our effort in the research world on. And it turns out that those do transfer well to other domains. There obviously is a lot of work that one needs to do to take those methods that you develop, for example, for videos and deploy them in other domains, but still the core principles do apply.
And this is a very unique opportunity outside school because you mentioned you directly talk to business people in certain field and figure out the main problem they wanted to solve. I guess how often do you do this in your current research director position, and how enjoyable do you enjoy the process?
So I've always been really enamored by this. I've loved solving problems, and so this is what it's like. You need to communicate with your partners. You need to understand what their problems are they're trying to solve, trying to understand the market they're going after, trying to understand the data they have, trying to understand what types of constraints they may have in solving these. So I've always really enjoyed that collaboration part of doing research, and this sort of steps in one further direction where you're collaborating not just with other scientists but with your business partners and making sure that you can help them solve the problem that they really need to.
I see. And is the current research sentence very open for the research to talk to any domain experts to dig out the possible problems to solve?
Yes, so the bank is very large. RBC has about 80,000 employees, and Borealis is a small part. We're only 100. So there are a large number of potential partners that we seek out and make sure that we collaborate with people who are able to provide us with the data and provide us with the challenges that we're able to solve for them. So that matchmaking to make sure that we work with the right partners is a very important part of what we do.
And the last question I also want to ask is, did you observe some synergy between your university position and the research direction positions?
Yeah, there's a lot of similarity between what one can do as a professor especially in Canada, with a lot of collaborations with industry. As a professor, I did a lot of collaborative grants with companies. So companies would come with their problems, and we would, as professors and students, try to work on technologies that would help them. That university-industry collaboration is very strong in Canada, and I think it's something that is really important to the success of artificial intelligence industries. Because many of the experts are either in universities or they are students who are studying at universities, making sure that there's a close partnership between companies and those academics is very important. And I felt as I moved to be the research director at Borealis, I found myself in a very similar role where I was interacting with people at the bank who had really important problems that they needed our help in solving, and I'm collaborating with them, finding the right ways to bring our researchers and engineers to try to solve those problems.
And now you also have the power to create internship positions, I guess.
Absolutely. I mean, we bring in a lot of students. I think it's just that those new ideas and the health of having a lot of people who are studying the latest and state-of-the-art techniques, writing papers about those, reading about them, and being able to implement them, bringing those people in on a regular basis helps to keep everybody fresh and excited and engaged in what they're doing.
So I want to change to another types of questions. So I understand you spent 1 year in Kyoto as at the year you graduate from undergrads, and you also visit Japan's every year a couple of times. Have you seen any particular patterns, and can you share about your perspective about how Japanese AI talents develop locally and also in abroad?
So it's a very interesting question, and I think that around the world, universities, governments, and industry are facing a major challenge, which is trying to attract AI talent. There's a shortage of people who are skilled in the type of research and software development that's necessary to be state-of-the-art in AI. When I was an undergrad in Japan, this was in the late 1990s, and it was a place to be for everything from speech recognition to multimedia, some of the real precursors to current AI boom that we have today. However, the investments in training that next generation of students have not necessarily kept up with the demand, especially from industry. However, in recent years, I think Japan and many other countries are experiencing a bit of a renaissance around having bigger investments in training more talent in AI.
I see, yeah. I think it's also reported in the news in Japan that more and more business, more and more sectors require well-trained AI scientists as well as engineers. And I also know you both work as the chair of the computer science departments, so you must have experienced how to have a plan to train AI scientists at scale from school and also attract new professors to the university, right?
Absolutely, and so my time as department chair was part of a really challenging time for recruiting top professors. We were both losing professors to industry as well as trying to attract that next generation of scientists. And I think what's really important is to allow professors flexibility. Many of them have talents that they want to use industry-type data and resources to act now and really change the world using the techniques they know how to do. Giving that flexibility to professors allows you to sort of retain really strong faculty who will teach the next generation of scientists, but at the same time be able to impact the world today.
I see. That sounds very interesting. Can you elaborate a little bit more in terms of what kind of flexibility and maybe using other people's or your own experiences?
Absolutely. So as an example, I feel like computer science as a discipline is becoming like medical schools. In North America, medical schools, doctors are teachers at those universities. They are practicing physicians who practice their trade and heal people, but at the same time train that next generation of doctors. Computer science and artificial intelligence specifically is becoming like that, where people who are in industry have vital information they need to train the next generation of students with and can give back and train that group of students. I think in the future we're going to see more of this. We'll see more and more part-time professors who are based in industry, who love giving back to training that next generation and will be teaching at the universities. Rather than being a full-time professor, I think that will become not a common type of situation in artificial intelligence.
I see. Well, that sounds a very good analogy. So just want to make sure I understand. So you think the new professor position will be you practice in the industry, you work with the real world problem, and you're making impact directly in the real world. But at the same time, you kind of summarize what you learn from handling those real world problems and put it into the latest courses, such that new generation AI talent could be benefit from those practice.
Absolutely, and I think the speed with which new discoveries are made in our world, the machine learning methods that we develop, the artificial intelligence methods that we develop, they're really moving so quickly that you need people who are on top of the latest and greatest methods and making sure that they're teaching those to the current students.
I see. That sounds wonderful practice. Yeah, so that's about like professor level experts. What about students level? Does the department or the government of Canada have some incentive for foreigners to come to Canada and study?
So I think one thing that's really important about this is that it's very much an international market for the brightest and the best students from around the world really want to come and study artificial intelligence. It's very competitive to get into PhD programs in computer vision, natural language processing, machine learning these days. There are very smart students from around the world who want to do that. And in Canada, that's where I'm based, it's a really open society where we accept a lot of immigrants, especially via foreign students who come in. Foreign students come in, they study computer vision at our universities, and there's a very easy path toward permanent residency and eventually citizenship. And it's very important because it keeps our companies strong, it keeps our universities diverse and have a lot of different viewpoints, and helps to strengthen the type of research we can do.
That's awesome. And so that's the progress happening in Canada. And throughout the past few years, since AI trend is really worldwide, have you also observed some activity or some individual case that happened in Japan that you can share about?
Absolutely. There's some really strong professors who have taken up positions at Kyoto University. For example, Ko Nishino has come there to take up a great position there. There are very strong professors at Nagoya University, as well as, of course, in Tokyo, and not just at Tokyo University, but also at other institutes such as NII, National Institute for Informatics. There are many strong professors here. The challenge as a university, though, is keeping up with demand. There are just lots of students want to study what it is that we know how to do, and we need to keep hiring more professors and bringing people in from industry who can train that group.
I see. So what I understand is some very strong professor is attracted back to the Japan community, but the government or maybe the whole society should promote more young professor joining the university and practicing in local industries, such that they can bring the latest knowledge to the students.
Yes, it's very important. It's important to have a broad set of people and have young group of talented scientists who are joining all the time, because bringing in those fresh ideas is what keeps the research vibrant and makes sure that we stay at the state of the art.
Wonderful. So I'm very interested from your past experience, what is the tips that you could encourage students to consider taking a PhD degree?
Yeah, so it's a very important thing for people to think about after having done a bachelor's in computer science or some very cutting edge area. Going on to study a PhD is really important, and I think it's very important for people around the world, in Japan, in Canada, in Taiwan, that those people think about studying the extra 5, 6, 7 years it'll take to really understand something. The feeling you get from studying for a PhD, where you know everything there is to know in the world about some topic, and in this case it's about machine learning, artificial intelligence, computer vision, things that are so important to the future of our world. It's such a special feeling to know that you're one of those people who's not only aware of what's going on in the world, all of human knowledge in an area, but also contributing to that, actually pushing us forward. I think that it's such an important thing that students from countries around the world think about trying to do that and help us to build a great society based on artificial intelligence.
I see. So basically in the AI domain, there's many opportunities for young talents to push the frontier further and directly contribute to the human society.
That's right. It's that ability to really contribute is something that's important. And the opportunities that come if you've done a PhD and you're able to really create things that don't exist right now. I think that both the type of job you can have as well as the type of impact you can have on the world is really very powerful.
Great. I think we should share this kind of thinking also in Japan and as back in Taiwan or many other countries to encourage more people to join the PhD degree.
Yes.
Thank you. Well, thank you very much for sharing all your experiences and your past research topic. Thank you very much.
You're very welcome. Thank you very much for hosting me.